Okay, guys, so welcome back to Challenge Lab, creating a VPC networking environment for the cafe. Now, this is the lab that we need to do for Module 6. Now, in this lab, we have to deal with a new requirement, and the objective of this lab is to create a virtual private cloud, and then we create an internet gateway, we create an ad gateway, and we attach them to a public and a private subnet. So at the end of the lab, this is the architecture we are going to end up with. It is basically a VPC with public subnet and private subnet. And the idea here that we will create a private EC2 instance in the private subnet where we will see how we can access this private EC2 from the bastion host. So the idea is that you will use your laptop to SSH to the bastion host, and from the bastion host, you can initiate another SSH session to the private subnet. So my lab is ready now, and I need to create a public subnet in task 1. So the first thing I'm going to do is to go to task 1, and in task 1, we need to go to the VPC. We will find that there is two VPCs here. There is the lab VPC, and this is the subnet we are going to work on. And we have a couple of default subnets. We will create a new subnet in the lab VPC. We call this public subnet. And this is going to be in the first availability zone. And you need to basically be careful here, because if you select the first availability zone, you need to make sure to select the first availability zone as well for the private subnet. Create a subnet. So that was basically task 1. For this VPC, before we move to task 3, we need to launch an ad gateway or an internet gateway, sorry. And that internet gateway will be attached to the lab. So this is going to be lab IGW, and we will attach it to the private subnet, which means all the resources that we have in the public subnet will be able to access the internet. So I'm going to select the lab internet gateway, attach it to a VPC, and select the lab VPC and attach an instance. Now in our route table, we need to configure for the lab VPC. We have a route table, and this is the route table with main equal yes. And you will find in the route that we have only a destination to 10.0.0.0/16. We need to add a route for any other IP, and this is because this is going to serve the public subnet. It's going to be basically leading us to the internet gateway. So select the internet gateway there and select the IGW that we just basically create. Now let us go to task 2. In task 2, we are going to go to the services, to the EC2. And in this case, we need to launch an instance. So we're going to select Linux Amazon EC2. It's going to be a T2 micro. We're going to select it to be placed on the network lab VPC with public subnet. And we need to basically later on give this machine basically elastic IP. So I can just keep it enabled here. Now add tag, and we will call this bastion host. Now in the security group, we want to create a security group for the bastion host, and we will call this bastion host SG. And this is basically will allow a TCP for port SSH 422 from anywhere, but I will select my IP address. So this will allow only my IP address from my homework, from my laptop, basically to connect the bastion host. To add an extra layer of security, launch, and now we need to launch it with the Vocarium key. Click on launch. The next step after you create this bastion host is to go to the elastic IP from the left and create and allocate a new elastic IP. That this will create a new elastic IP. Now what I need to do is to basically associate that elastic IP to the bastion host that I just create. Now this is maybe you need to refresh the page until the instance is fully running, still in pending state. Go back now to the Elastic IP, and from action, associate, and now you should see the bastion host running. You could also select the private IP, and you can allow this Elastic IP to be reassociated and associate. The next step, guys, is to test the connection. I'm going to show you this now. You need to get the Vocarium key. So there is a few things we need to do here is to go to the details, show, and from the show, we need to download the PIM file if we have Linux or Mac OS, and the PPK file if you want to use PuTTY with Windows. So I'm going to download the PIM file. Now in my laptop here, it is saved as labuser.pim. So now I have the labuser downloaded to my computer. Now let me just create or open the terminal application, and I need to navigate to the download folder. And now I need to create chmod 400 for the labs user PIM file. Now I need to test if I can connect to the machine. So I will use -i labs user, and this will be EC2 user. Now we want the Elastic IP of the instance. So the bastion host instance is taking this Elastic IP, which is the same one I just created. And now paste this here, and you should be able to get access to the bastion host. So I successfully now connect to the bastion host, as you can see. So by this, we finish task number 4. Now in task number 5, guys, we need to go back to the VPC. And from the VPC, we want to go to the subnet, and we create a subnet, and we call this in the lab VPC a private subnet. Again, this should be in the same subnet as the as the public subnet, and the IP address for this subnet is going to be 10.0.1.0 with a /24, and then create a subnet. The next step is to go and create an NAT gateway. As we know, the resources that we will create in the private subnet, they might need access to the internet for software update and so on. So this will be lab NAT gateway, and we want it to be operated in the public subnet. Okay, and NAT need normally an Elastic IP, so we will allocate an Elastic IP, and we keep the connectivity type to be public, and now create a NAT gateway. Go into the route tables, create one, and call this private route table. And this will be in the lab VPC. Now, if you edit that route table, if you select that a new private route table, and just be careful because this is our lab route table, lab VPC route table, where we have the public route table. Now, this is a bit different from previous lab because basically it is the main route table. In this VPC, because we create it with the default wizard with one public subnet, it is basically giving us the public route table, yes. Now the private subnet route table, so this is the private subnet route table, it will show us with main equal no. Now in the routes, we need to edit the routes here, and we need to add basically for any other IP, and we will associate this with the NAT gateway, the one that we just create, and save changes. Now the subnet association, if you recall, we need to associate with this route table the private subnet. It's also worth now going back to the public route table and checking that this is associated with the public subnet. And you can see I have not really associated this with the public subnet yet. So now my route table is associating the public subnet, and my private route table is associating the private subnet. Now we want to create now an EC2 instance in the private subnet. So let's go back to the EC2. Maybe you can open it in a new tab. This will allow you to have multiple pages at the same time. Launch an EC2 with Amazon Linux 2 AMI. The type of the EC2 is going to be T2 Micro, and it will be placed on the lab VPC in the private subnet. And there is no need to give this a public IP address because it will be a private subnet. Add a storage, add tag, and we will call this instance name will be a private instance. Now, the security group, we are going to call this instance with the private instance security group, allow access to private instance from the bastion host, because this security group will allow us to basically connect to our Elastic from the bastion host security group. Now, if you go to the custom and you put basically SG there, you type SG, you will get the bastion host security group. Review. Now the machine here, it will create a new key pair. We will call this VOC key 2. Download it to your computer, guys, okay? And then launch the EC2. Now this VOC key, we will use it later on to connect to our machine from the bastion host in the public subnet as well. So now we need to focus on configuring our SSH client for SSH pass-through. So now we have two machines at this stage. We have a bastion host and we have a private instance. And now we need to connect to this private instance from the bastion host. Now to do task 8, guys, we need to configure our SSH client. If you have Microsoft Windows, you need to download P-Agent. It's another software that you can basically manage multiple AWS SSH certificate. Feel free to do so, guys, and follow the instruction in task 8. In my terminal here, I have two keys. I have the lab user key and I have the Vocarium key. Okay, now this Vocarium key in my download folder, I'm going to use to connect to my machine on the private subnet. So the first thing I need to go and do is chmod 400 voc key 2. And the next thing now is to add and to execute the command in step number 29, where basically we will add the Vocarium key to our SSH pass-through. So you could do the following. You could SSH -add -k and the voc key 2. So now we add this identity. You can verify this SSH -add -l, and you can see now we have Vocarium key and lab user as well there. To verify that you have the correct settings, you could also add again the lab's user key. Maybe you have a lab user from previous lab, so you can just verify that this is the lab user I just downloaded today. Now let us clear this window here And in task number 31, or in step 31, we need to make sure that we can connect to the private IP address of the instance in the private subnet. So I will SSH -A to the bastion host, and now I need to connect to the private EC2 instance using SSH EC2 and the IP address of the private instance, which is 10.1.72. Okay, I am in. Now try to check that your NAT gateway is working by just doing this ping. And as you can see, I have an internet connection. Now we need to test the SSH connection, and this is what we did in step 32, 32, and 33, and 34. And now we can move successfully to task number 10. Now in task number 10, we need to create a network access list. So we need to go to the Amazon VPC, and we have a network access list. Now you can see there is an access list already created in the lab VPC. It has an inbound rule with a *100 allow, and also outbound with 100 allow all traffic. So we need now to create a new custom network access list. We will call it lab network access list. And this will be in the lab VPC, and create. Now that lab network access list, we want to configure it to allow all traffic. So we add a new rule, we give it the name or the number 100, so it will be executed, and we call this all traffic allow from any IP. Save, and then we go to the outbound and we do the same. Remember, this access list is stateless, so all the inbound and outbound traffic need to be evaluated. Allow all traffic, allow from any IP. Now that's what we need to do for network connection 37. Now we need to test our custom network access list. Now this subnet, this access list for lab network, it needs to be associated with the private subnet only. So if you go and save changes, and if you verify or you refer back to the actual diagram of the lab, you see the custom network access list will be associated only with the private subnet, not with everything. So in this task here, we need to go and create basically a new EC2, and that EC2 will be in the private instance, in the public instance, and we will call it a test instance. So select T2 micro, configure, it will be in the lab VPC, in the public subnet, and we will create this in the public subnet. We only need the private IP so far for this test instance, so we are not going to have anything more than that. Now click add and previous. Let me check the tags, add storage, add tags. Now in the tag, this instance will be called now test instance. So this is next security group. Now the security group we will have, it will be called test security group. And this will allow only all ICMP traffic. So this is going to be ICMP traffic, IPv4. And now review and launch. So once is this fully launched, in this task here, we want to test that on step number 40, we want to test that we can ping that machine, the test instance, private IP address from the private instance that we have in the private subnet. So let us wait until this test instance get an IP address. Now, sometimes this will take a few minutes. And at this step, you will have a bastion host in the public subnet, you have a private instance in the private subnet, and you have a test instance in the public subnet where we will use it just to test our connection between the private and the public subnet and our custom security group. Now, the test instance is getting an IP address, as you can see here. It is 10.0.0.213. Go back to your terminal. I am in the IP address of the private subnet, and I could simply verify this by looking to this IP address after the EC2 user. So I could go to the private instance and check that this instance IP is 10.0.1.72. And now let us ping the private IP address of the test instance. You can see now I have a successful ping, which means everything is working. We need to leave the ping utility running. And now let us move to step 42. We need to go to the network access list. And in that step, they want us to block now all the traffic from this private instance to the test instance. So we need to go to the custom inbound, and we edit, select the lab network inbound, and now we edit the inbound rule. We need to add the rule. Now, if you add the rule like 200, this will be evaluated after the rule 100, so it won't have an effect, but you need to have a rule between star and 100. So let us give it the number 41. And we want only to have a custom or all ICMP traffic. It will be a custom ICMP traffic, and we want to basically block anything from the private IP address of the test instance. So what's the private IP address from the test instance? Is this IP. Copy that IP, paste it here, and put /32, and just make this deny and save the change. Because this is an access list, you need to do this in both direction, in inbound and outbound. Again, paste the IP address of the private subnet and then click on deny and save the changes. Now, in a few seconds, the ping should stop. And as you can see here in my terminal, the ping is not moving any further because it has been blocked. So this is pretty much what you need to do the lab. Now, at this step, go to the details, guys, answer the questions and submit your work. Thank you for seeing this video, and see you in the next one.